Hi folks, Harry Frank for Red Giant here, and in this tutorial I'd like to show you what's new with Trapcode Particular 2.2. There's lots of little things in here that are going to make your life just a little bit easier. So let's start with the first thing, which is a new still emitter mode inside layer emitters. That's a mouthful. So let's back up here. When we use emitters and emit particles in Trapcode Particular, we have a lot of different options. One of these is a layer option, and this allows us to define a 3D layer, like this one right here, to be used in Trapcode Particular. Now, depending on the way the layer is being used, there's different modes you would want to use in particular. Inside here, I have a text animation that goes like this, and I also have a still version of this. Now, depending on how this layer is going to behave, if it's animated or if it's still, we would want to choose different layer emitter modes. And let me show you why you would want to do this. So let me set this to an animated mode. So let's go to our layer emitter right here and look at our layer sampling inside layer emitter inside the emitter section. By default, layer sampling uses current time. So this layer right here is moving up and it's changing over time. So let's say right about here it emits a particle because the alpha channel is not 0 right here. And as the text moves up, we can still see the particle. But as this alpha channel on this layer right here at its current time goes away, right about here, the particle disappears because it's sampling it at the current time. It samples the alpha channel at the current time. So if something changes over time, current time isn't actually the best way to go about it. This is why we would want to use something like particle birth time. And this has always been here, but this is perfect for things that actually change over time. So let's say I'm actually just using a still version of this. So now this is not moving, so it doesn't really matter. So current time would actually work pretty well for this. So what's the problem? Why add another type of layer sampling in here? So if I leave this layer sampling set to current time, and I go down to the aux system, which allows us to generate particles from other particles, we'll see what's actually going on with the layer sampling in the alpha channel area. So if I go to aux system and turn this on, that default method of current time sampled the alpha channel in a different way, and actually kind of sampled it in an undesirable way where it actually emits particles, or it doesn't actually kill the main particles, it just makes them invisible. So we end up with aux particles being emitted even though they shouldn't be there. So if I go back to that emitter section, layer emitter, layer sampling, and set this to still, it behaves almost exactly like current time, but what it does is kill the particles at the 0 alpha regions. However, it still assumes that it is a still image. So if I had animation in here, we're going to see that same behavior that we had with current time, where we can have particles perhaps disappearing. So it's good to know what the different modes do and when you'd want to use them. Moving on, another function that has been slightly updated. It's actually a very subtle update, but inside World Transform, the parameter names have been changed. They've actually added one character, which is W, which is for world. Now the problem before was that X rotation, Y rotation, Z rotation, as well as X offset, Y offset, and Z offset were not unique names within the plugin. And therefore, if you tried to use expressions to work with these, you actually had sort of an undesirable result, because the expression would actually work with the first parameter that was a match of the name. So even if you wanted to use world transform, it didn't really work because the parameter names were duplicated elsewhere. So in this case where I have, let's say, two different layers, I have this orbiting layer and I have this inside layer. If I wanted to link them together with a offset and link them together via expressions with an offset, I can now do that because my X offset of world transform now has a unique name. So in this other particular layer, which is the inner orbit, I've set these simple expressions to link to the other layer, the outer orbit effect particular X offset W. Now it's a minor change, but it can actually be quite useful. The next thing I'd like to talk about is something called Light's Unique Seeds, and you'll find this under the emitter type when you're using light emitters. under emission extras, there's an extra checkbox called lights unique seeds. Now, one of the cool things about particular is that we can use lights to locate where particles are emitted. In fact, I can use multiple lights and inherit the color from the lights to make different instances of the same effect. So in this case, I've got fireworks emitting from 3 different lights. It's this same layer of particular. I've got 3 different colors on the lights in 3 different positions, and therefore it's emitting particles at each of the positions. However, when I bring these very close together, you'll see that the exact same position is duplicated. So all the particle positions are exactly the same between the two. That's where this new checkbox comes in. When I click on Lights Unique Seeds, each of the light emitters will have its own random seed. Now take note, this actually stops working at a very specific number, which is 65,356, which is coincidentally 2 to the 16th power. I'm sure there's a technical reason for that, but generally if you leave this at the default setting of 100,000, that will take care of this. Some older presets will use a random seed of 0. So if you do use an old preset, make sure to set the random seed to a higher value. 100,000 is a pretty easy way to go about that. Now another place where lights unique seeds comes into play is when you're using the streaklet particle. So again, when we have light emitters all a bit close together, we can see that the pattern is actually duplicated between all of the streaklets. And sometimes you don't want that. So if we go to this light unique seeds checkbox, you'll find that this also affects the random seed for the streaklets. Now, one overall improvement you'll find in Trapcode Particular is that the maximum visible particles has been raised to 20 million. Now, that might seem like quite a bit, and you might think, how in the heck would I ever use 20 million particles? Well, it actually becomes pretty possible. So if I have a fairly high particles per second count, in fact, I max it out at 1 million particles per second, and I have these at the default lifespan of 3 seconds, so they'll be there for a few seconds. And also, I go down to the aux system and I have each of those particles emit 5 particles per second. We're going to end up with quite a few particles. Now I can see the particle count if I pull up the info window, and under After Effects, Preferences, Display, I turn on Show Rendering Progress in Info Palette and Flowchart. This will give me my particle count, and this will take just a second to render because, well, there's a lot of particles. So now you can see in my info palette here that I have a total of 35,700,000 odd particles. Some of those have either drifted off frame or perhaps have gone down to a 0 opacity. So I only have 13 million particles. So if you've ever done any very high particle count stuff like this to get this sort of smoky kind of feeling, you'll certainly appreciate the particle count being raised up a bit so you don't get any particle overflow errors. Now, while we're on the topic of high particle counts, when you've animated your particles per second and you'd like to temporarily lower the particles that you've got, you are kind of stuck here. You could go in and you could use expressions to sort of divide the particles per second if there's a certain case true, like an expression switch or whatever. However, there's an easier way to temporarily lower this particle count. As you can see, my computer's struggling to calculate all 35 million of these particles. So I can go down here to the rendering section, and I'd like to sort of temporarily lower this so I can work a little more smoothly with my emitter settings and all that. So I can set this particle amount as a percentage of the original amount. So let's say I set this to 5%. Now, because I was working with such a large particle count before, I might want to bump this size up a little bit. There we go. So now this is a lot easier to manage, and then just before I hit render, I can actually jump back down to that particle count and change it from that setting of 5 to 100. And actually I can overcrank this above 100, although I'm not going to do this because I have quite a bit of particles in here. But let it be known that the particle count can actually be overcranked over 100 to values above 100 to overcrank the particle amount. But I'm not going to let that render. This brings us to a new section, and this actually opens up quite a bit of possibilities for Trapcode Particular. Now, I'm going to cover the theory of this, and the practical application of this is demonstrated quite well in a tutorial done by the creator of Trapcode Particular, Peter Norby. So he goes through a very detailed explanation of how to set this up. But what I want to cover is the theory behind what is actually going on with this stuff. So you have a nice reference for this. And what I'm talking about is a new function inside Trapcode Particular in the layer emitter section where we have a layer RGB usage that is XYZ velocity. Now, it doesn't say this here, but what this actually means is that we are using motion vectors to create the particle velocity. So red is directly matched to X, green is directly matched to Y, and blue is directly matched to Z. So if I go into my example project here, I've got a pre-comp here that has a solid, and there are two colors applied to either side. Now, just to make this easy on me, I've linked the colors via expressions outside the comp here, so I can actually change the colors on either side. So if I change this color here, you'll see the color change in the solid. Nothing tricky there. I'm just doing this to make life easier. So I'm emitting particles from this layer. So this layer is called motion vector. And I've set the layer usage to RGB XYZ velocity. So you notice the particles on the left side are emitting to the left, and the particles on the right side are emitting to the right. So let's take a look at this color right here. So again, we're applying red, green, and blue to X, Y, and Z. We have positive and negative direction because this is a velocity. Velocity has positive or negative direction. So a value of 127 for any of these colors will mean a velocity of 0. So notice these particles are no longer moving. If I set red to 0, this is the maximum negative velocity for X, and therefore these will move in a negative direction in the X axis. If I set this to 255, they will move in the positive X direction. If I go to my B color, blue, this will control the Z axis. So I can have particles on this side start to move toward the camera by setting this to 255, or I can set them to move away from the camera by setting this to 0. Now, how you get motion vectors into After Effects is going to depend on your type of project and what you want to do. Now, you can get motion out of live footage by using a plugin called Twixtor, and 3D programs such as Cinema 4D are completely capable of doing motion vector passes. Lastly, one subtle thing that has been added in the turbulence field. If I have particles that are moving through space, and I go to the turbulence section to affect their position with the fractal field, and the particles will be moving through this fractal field. Prior to 2.2, this effect position value could only be positive. However, now we have the possibility to actually set this to a negative direction to affect the particles in the opposite direction. That about covers it. That's what's new in Trapcode Particular 2.2. My name's Harry Frank for Red Giant. Thank you so much for watching.